Perhaps you've wondered, as you drift toward sleep tonight, who the oldest living witnesses on our planet might be. While empires have risen and fallen, while humans have come and gone through the centuries, what beings have silently observed the passage of time for thousands of years? What eyes have watched civilizations emerge, flourish, and fade into dust? What living memory stretches back to times we know only through ancient texts and archaeological remains? In this gentle exploration tonight, I invite you to the world of perhaps the most extraordinary living beings on our planet, the sequoias, giant sequoias, and coast redwoods. These massive trees stand as silent sentinels, witnesses to much of human history. Some have lived for more than 4,000 years. They were already seedlings when ancient Egypt was in its prime, when the first pyramids were being constructed, when writing itself was just beginning to spread across human societies. As you rest now, perhaps lying in bed or settling into a comfortable chair, close your eyes for a moment and imagine yourself in the misty forests of North America, surrounded by these ancient giants. Looking up, you see trunks wider than your living room, bark the color of cinnamon and auburn, rising almost 300 feet toward the sky, so tall you must tilt your head all the way back to glimpse their uppermost branches. The forest floor beneath your feet is soft with centuries of accumulated needles and fallen cones. With each step, you're walking on history itself. The air carries the fresh scent of pine and resin, clean, sharp, and invigorating against the background of decay and renewal. Around these trees, time seems to flow differently. Days, years, centuries. For them, it's all just a gentle rhythm of seasons, a slow dance of growth and persistence. While a human lifetime passes in what feels to them like the blink of an eye, they remain, growing imperceptibly, adding another thin ring to their massive trunks, witnessing the world change around them. Tonight, as your thoughts begin to slow and your breathing deepens, we'll journey through time with these remarkable trees as our guides. We'll explore how they live, how they've survived catastrophes that wiped out countless other species, and what secrets they might hold in their ancient cells. What would it be like to live for thousands of years, to feel the same sun warming your branches through millennia, to stand rooted in one place while the world transforms around you? These trees have experienced climate shifts, the comings and goings of countless species, the arrival of humans, and the dramatic changes we've brought to the landscape. They've weathered storms that could tear apart buildings, survived fires that would reduce human structures to ash, and persisted through droughts that lasted decades. Their resilience is not just inspiring, it's almost beyond comprehension for beings like us, who measure our lives in mere decades. There's something deeply calming about contemplating such ancient life forms in our fast-paced world, where everything seems designed to capture our attention for just a moment before the next distraction arrives. These trees remind us of a different way of being. They embody patience, persistence, and a connection to time that we, with our brief lives, can barely comprehend. Some scientists believe that certain sequoias may be effectively immortal. Unlike humans, they don't seem to have built-in genetic limits to their lifespans. They don't age in the way we do. They could theoretically live forever, if not for external forces like disease, fire, or human activity. What might it be like to exist without sensing your own mortality? As you breathe deeply now, imagine the countless breaths these giants have taken over thousands of years. drawing in carbon dioxide and releasing oxygen in a rhythmic exchange that has helped sustain life on our planet. Each of us owes a debt to these ancient beings for the very air we breathe. Tonight, we'll travel through time with these majestic sentinels, from their prehistoric origins to their uncertain future in our rapidly changing world. We'll discover the intricate ways they've adapted to survive for millennia, and what they might teach us about resilience and the long view of life. So settle in, relax your body, and let your mind drift into the misty groves of Earth's most ancient trees. Let's walk together through forests where time itself seems to slow down, where a human lifetime is just a moment in the long, slow breath of these magnificent living monuments. This is not just their story, it's the story of time itself, of persistence against all odds, and of the quiet wisdom that comes from standing witness to the passage of millennia. These ancient trees have a story to tell, if only we slow down enough to listen.
To truly understand the sequoias, we must first journey back, not just centuries, but millions of years, to a time when the world was a very different place. Close your eyes and imagine the Jurassic period. About 200 million years ago, the continents are still joined in the supercontinent of Pangaea. The air is warmer, moister, and filled with different sounds than those we know today. In this ancient world, dinosaurs roamed the landscape, their footsteps creating tremors that vibrate through the soil. The skies are filled with pterosaurs gliding on leathery wings, and covering much of the land are vast forests of primitive conifers, the distant ancestors of our sequoias. These ancient relatives of today's redwoods were part of a family called Cupressaceae, the cypress family. They dominated the landscape for millions of years, spreading across what would eventually become separate continents. Their lineage is ancient beyond imagining, stretching back to times when mammals were still small, scurrying creatures hiding in the underbrush. As millions of years passed, continents drifted apart, climates changed, and many plant species went extinct. But the ancestors of sequoias proved remarkably adaptable. They survived the extinction event that wiped out the dinosaurs 65 million years ago, persisting through dramatic climate shifts and changing landscapes. By about 35 million years ago, in the Oligocene epoch, sequoias and redwoods had evolved into forms very similar to those we know today. They had spread across the northern hemisphere, growing in forests across North America, Europe, and Asia. Their massive trunks and towering heights were already characteristic features, though they lived in a world still quite different from our own. Imagine these forests spanning across continents that were still taking shape. The Himalayas were just beginning to rise from the collision of India with Asia. The Alps were still forming. North America was separated from Asia by a land bridge that would later become the Bering Strait. Through all these geological transformations, the sequoias persisted, their genetic lineage unbroken across deep time. But then, starting about 20 million years ago, something began to change. The global climate started a long cooling trend. The warm, moist conditions that had allowed sequoias to thrive across the northern hemisphere gradually gave way to cooler, drier climates. Slowly, over millions of years, the range of these magnificent trees began to contract. In Europe and Asia, sequoias and redwoods eventually disappeared entirely, unable to adapt to the changing conditions. In North America, they retreated to smaller and smaller ranges, finally finding refuge in pockets where the local climate remained hospitable. By about 5 million years ago, they were largely limited to the western regions of North America, particularly in what would become California. This is where we find them today, the last remnants of a once global forest, the final representatives of an ancient lineage that has witnessed the rise and fall of countless species, the shifting of continents, and the transformation of Earth's climate again and again. The giant sequoias, Sequoia dendron giganteum, now grow only in a narrow band along the western slope of the Sierra Nevada mountains in California. The coast redwoods Sequoia sempervirens are found in a thin strip along the Pacific coast from central California to just across the Oregon border. These small, isolated groves are all that remain of forests that once spanned continents, yet within these limited ranges, they continued to thrive, growing to sizes that defy imagination. The General Sherman tree, a giant sequoia in Sequoia National Park, stands 275 feet tall with a base diameter of 36 feet. It's estimated to be between 2,300 and 2,700 years old, and is considered the largest single-stem tree on Earth by volume. Not the tallest, not the widest, but in terms of total wood volume, nothing else comes close. The coast redwoods, meanwhile, include the tallest trees on Earth. The current record holder, a tree nicknamed Hyperion, stands at an astonishing 379.7 feet, taller than the Statue of Liberty, including its pedestal. These trees routinely reach heights of over 300 feet, creating an environment so unique that it has its own weather patterns and ecosystems. Now, as you relax deeper into our journey, let's step into one of these ancient groves and experience what it's like to stand among living beings so old and so massive that they seem to exist in a different time frame than our own. Imagine yourself walking along a forest path in the early morning. A gentle mist hangs in the air, softening the outlines of the massive trunks that rise around you like the columns of a natural cathedral. The first rays of sunlight filter through the canopy hundreds of feet above, creating beams of golden light that pierce the mist in dramatic shafts. The forest floor is soft beneath your feet, cushioned by centuries of accumulated needles, bark, and decomposing plant matter. Each step releases the rich, earthy scent of humus mixed with the clean, sharp fragrance of conifer resin. The air feels different here, cooler, moister, somehow older than the air outside the grove. As you walk, the sounds of the modern world fade away, replaced by the subtle music of the ancient forest. There's the gentle sigh of wind through branches far above, the occasional soft thump of a pine cone falling to the forest floor, the distant tapping of a woodpecker, and the rustling of small creatures moving through the underbrush. But most striking is the quality of the silence between these sounds, a deep, profound quiet that seems to resonate with time itself. It's not the absence of sound but rather a presence, as though the accumulated silence of thousands of years has become almost tangible. In this quiet, you can almost hear the slow, patient growth of the.
Look up, and you'll notice the unique bark of these ancient trees. The giant sequoias have fibrous bark that can be up to 2 feet thick, an adaptation that protects them from forest fires. Its color ranges from cinnamon to chocolate brown, with deep furrows creating a pattern of ridges and valleys. This bark contains tannins that not only give it its distinctive color, but also make it resistant to insects, fungi, and fire. The coast redwoods, meanwhile, have reddish-brown bark that feels surprisingly soft and fibrous to the touch. It too can be very thick, especially on older trees, providing protection against the elements and helping to make these trees among the most fire-resistant on Earth. Touch one of these massive trunks, and you're touching something that may have been alive when Rome was founded, when Socrates was teaching in Athens, when the Great Wall of China was being built. The bark beneath your fingers has weathered thousands of seasonal cycles, countless storms, periods of drought, and even the small ice age that chilled the northern hemisphere from the 14th to the 19th centuries. As you continue your walk, you begin to notice the unique ecosystem that exists within and around these ancient trees. The sequoia groves are not just collections of massive trees. They're complex communities of interdependent organisms, each playing a role in the resilience and longevity of the whole. Look closely at the forest floor, and you'll see a rich carpet of smaller plants, ferns, wildflowers, mosses, and fungal networks that help decompose fallen material and recycle nutrients. In the understory, younger trees and shrubs grow in the filtered light, ready to take their place, should one of the giants fall. Above, in the branches of the sequoias themselves, entire ecosystems exist that are rarely seen by human eyes. Some of the oldest coast redwoods develop what scientists call canopy soils, accumulations of dust, needles, and decomposed material in the crotches of branches hundreds of feet above the ground. These soils can be several feet deep and support entire gardens of plants growing in the sky. Researchers who have climbed these arboreal giants have discovered ferns, huckleberries, even small trees growing in these elevated gardens. They've found salamanders living their entire lives in pools of water collected in tree hollows 300 feet above the ground, never descending to the forest floor below. Some coast redwoods are so large and complex that they create their own weather. The uppermost branches actually condense fog from the air, creating precipitation that waters the tree and the surrounding forest even during dry periods. A single large redwood can condense several thousand gallons of water during foggy periods, much of which drips to the forest floor, sustaining the ecosystem below. The roots of these giants are surprisingly shallow for their enormous size, often no more than 12–14 feet deep. But they spread outward for hundreds of feet, intertwining with the roots of neighboring trees. Contrary to what you might expect, they don't stand alone. Their roots often graft together underground, creating networks that share resources and information, supporting each other through storms and droughts. This interconnectedness extends beyond what we can see. Beneath the forest floor, fungal networks known as mycorrhizae form symbiotic relationships with the trees, extending the reach of their root systems and facilitating the exchange of nutrients and chemical signals between trees. Through these wood-wide webs, the ancient sequoias are in constant communication with the forest around them. As you wander deeper into the grove, the scale of these trees begins to sink in. Some are wide enough that tunnels have been cut through their bases large enough for cars to drive through, a practice, thankfully, that has been discontinued. Others have burned scars from fires that occurred before European settlement of North America, yet they survived and continued growing. The age of these trees is difficult to truly comprehend. The oldest confirmed sequoias was about 3,500 years old. Coast redwoods can live more than 2,000 years. The oldest known tree of any species is a bristlecone pine named Methuselah, estimated to be about 4,850 years old. These trees were seedlings when humans were first developing writing. They were already ancient when Rome was founded, when the pyramids were built, when most of the religious texts still read today were first written down. To put this in perspective, if the entire history of human civilization were compressed into a single 24-hour day, some of these trees have been alive and growing for more than 16 hours of that day. They've been silent witnesses to the rise and fall of countless human societies, to wars and revolutions, to the development of technologies that would eventually threaten their very existence.
Yet through it all, they've continued their slow, patient growth, adding cells to their massive trunks, extending branches toward the sky, dropping seeds that might one day become thousand-year-old giants themselves. Their time scale is so different from our own that we can barely perceive their movement or growth. In the time it takes you to read this sentence, a sequoia has changed hardly at all, but give it a century, and its transformation is unmistakable. As the sun rises higher, the mist begins to burn away, revealing more of the forest around you. Sunlight dapples the forest floor, creating patterns of light and shadow that shift with the gentle breeze. You find a fallen log, perhaps from a tree that fell centuries ago, its wood still slowly decomposing, and sit for a moment, absorbing the atmosphere of this ancient place. In the quiet of the forest, time seems to slow down. The urgent pace of modern life feels distant and somehow less important. Here, surrounded by living beings that measure their lives in millennia rather than years, your perspective shifts. The concerns that seemed so pressing just hours ago now appear in a different light. What are a few decades of worry in a place where centuries pass like seasons? What is the significance of our brief lives compared to these trees that have watched civilizations rise and fall? Yet rather than making you feel insignificant, there's something comforting in this realization, a sense that you are part of something larger and more enduring than yourself. As you sit quietly, breathing the cool forest air, you begin to feel a connection to these ancient beings, not mystical or supernatural, but the simple, profound connection of one living thing to another. Different as we are in size, lifespan, and form, we share the same sunlight, the same soil, the same cycles of growth and rest. We are fellow travelers on this planet, even if our journeys span vastly different timescales. And in this connection, there is a gentle lesson about patience, persistence, and the long view of life. These trees have survived not by rushing or striving, but by slow, steady growth, by adaptability and resilience in the face of change. There's wisdom in their silent presence, a reminder that some of the most important processes in life cannot be rushed, that true growth and resilience come not from speed, but from depth and patience. As we continue our journey with these remarkable beings, we'll explore how they've managed to survive for so long, what threats they face in our rapidly changing world, and what their future might hold. But for now, simply rest in the quiet presence of these ancient giants, letting their silent wisdom wash over you like the gentle mist that surrounds their massive trunks in the early morning light. As you continue your walk among the ancient sequoias, perhaps a question has begun to form in your mind. How exactly do these remarkable trees achieve such extraordinary longevity? What secrets do they hold that allow them to live not just for centuries, but for millennia, while most other living things come and go in the blink of a cosmic eye? This is a question that has fascinated scientists for generations, and the answers reveal a combination of fascinating adaptations, fortunate circumstances, and remarkable resilience. Let's explore some of these secrets together as the afternoon sun filters through the canopy above. One of the first keys to the sequoia's longevity lies in their bark, the thick fibrous covering that gives them their distinctive appearance. The bark of a giant sequoia can be up to 2 feet thick, creating a formidable barrier against many of the threats that might kill other trees. This bark contains high levels of tannins, the same compounds that give red wine its distinctive flavor and color. These tannins make the bark not only resistant to fire but also to fungal infections and insect attacks. When a forest fire sweeps through a sequoia grove, most other trees might be severely damaged or killed, but the sequoias stand firm, their thick bark insulating the living tissues beneath from the heat. The tannins in the bark don't burn easily, and their chemical composition actually helps protect the tree. After a fire passes, you might see the outer layers of bark charred black, but the tree itself remains unharmed, continuing its patient growth as though nothing had happened. This fire resistance isn't just a defensive mechanism, it's actually part of the sequoia's reproductive strategy. The heat from forest fires helps open their cones, releasing seeds onto the newly cleared forest floor. The fire clears away underbrush and competing species, creates nutrient-rich ash, and opens up the canopy to allow more sunlight to reach the forest floor, all ideal conditions for sequoia seedlings to establish themselves. In a beautiful example of evolutionary adaptation, these trees don't just survive fire, they've incorporated it into their life cycle, using what would be deadly to other species as an opportunity for renewal and reproduction. Some of their cones can remain on the tree for up to 20 years, waiting for the heat of a fire to release their seeds at precisely the moment when conditions for germination are optimal. But the remarkable longevity of sequoias goes beyond their fire resistance. These trees have developed multiple layers of defense against the various threats they face throughout their long lives. Consider their chemical defenses. Beyond the tannins in their bark, sequoias produce a variety of compounds that help protect them from fungi, bacteria, and insects. Their heartwood, the dense central core of the trunk, contains extractives that make it extremely resistant to decay. Even after a sequoia dies and falls to the forest floor, its wood can resist decomposition for centuries, sometimes remaining intact for more than 1,000 years. This is why you might see fallen sequoias in the forest that show little sign of decay, despite having been on the ground for hundreds of years. Their wood is so naturally resistant to rot that early loggers sometimes found it too difficult to process. The same qualities that make it durable in nature made it challenging to mill and work with, using 19th century technology. Another key to their longevity lies in their size itself. By growing so tall and massive, sequoias literally rise above many of the challenges that might threaten smaller trees. Their lowest branches may be 100 feet or more above the ground, well above the reach of most forest fires. Their massive trunks require enormous amounts of energy for any pathogen to fully invade. They're simply too big for most threats to overcome completely. The sheer volume of living tissue in a mature sequoia creates a buffer against localized damage or disease. If one part of the tree is injured, the vast resources of the whole can be mobilized to compartmentalize the damage and continue growing elsewhere. It's somewhat like how a small cut might be a minor inconvenience for a human but potentially fatal for a much smaller organism. Scale matters when it comes to resilience. But perhaps most fascinating is the way sequoias deal with the cellular aging processes that eventually kill most other organisms. While humans and many other species have cells with a built-in limit to how many times they can divide, known as the Hayflick limit, trees work differently. The growing tips of trees contain meristematic cells, plant stem cells that can continue dividing indefinitely without showing signs of aging. Unlike animals, whose entire bodies age as a unit, trees essentially grow new bodies each year in the form of new rings of cells. The outermost layers of a sequoia, the parts actively transporting water and nutrients, are always young, regardless of how old the tree as a whole might be. In a very real sense, parts of the tree are always young, even as the whole organism persists through centuries and millennia. Scientists have found no evidence of senescence, the biological process of deterioration with age, in sequoias that die of old age. When these ancient giants do fall, it's typically not from old age in the way humans understand it, but from external factors, storms that finally overcome their stability, fires that eventually break through their defenses, or human activities that disrupt their environment. From a certain perspective, sequoias could potentially live indefinitely if external conditions remained favorable. There appears to be no genetic time bomb ticking away inside them, no predetermined lifespan written in their DNA. Their longevity is limited not by internal constraints, but by the accumulation of environmental challenges over time. The statistical probability that, given enough centuries, something catastrophic will eventually happen. This brings us to another question that might have crossed your mind as you walk among these giants. What does kill a sequoia after it has survived for centuries or millennia? What finally brings down these seemingly immortal beings? Often, it's the simple physics of gravity combined with soil conditions. As a sequoia grows taller and more massive over the centuries, the stresses on its trunk and root system increase. Eventually, if the soil becomes saturated with water after heavy rains, or if erosion exposes part of the root system, even these giants can lose their balance and topple. When a mature sequoia falls, the impact is literally earth-shaking. The ground trembles as hundreds of tons of wood crash down. The fall of a giant creates a new clearing in the forest, allowing sunlight to
Human activities, of course, have introduced entirely new threats. Logging claimed vast numbers of these ancient trees before protections were put in place. Air pollution, Climate change and alterations to natural fire regimes all create challenges that these trees never faced during their evolutionary history. But before we explore those modern threats, I'd like to share something truly remarkable about how sequoias reproduce, a process as patient and extraordinary as the trees themselves. Unlike many plants that can reproduce after just a year or two of growth, sequoias take their time. A giant sequoia may not begin producing viable seeds until it's 20 years old, and it doesn't reach its prime reproductive capacity until it's about 250 years old. Yes, you heard that correctly. These trees don't hit their reproductive peak until they've been alive for 2.5 centuries. The cones of a giant sequoia are surprisingly small for such massive trees, about the size of a chicken egg. Yet each cone contains between 30 and 50 tiny seeds. These seeds are minuscule, about the size of a flake of oatmeal, and extremely light. It would take about 91,000 of them to weigh a single pound. A mature sequoia can produce an astonishing number of these cones each year, up to 11,000 on a single tree. This means that an ancient sequoia might release over 300,000 seeds annually. Throughout its long reproductive life, a single tree might produce more than 300 million seeds. Yet despite this abundant production, very few of these seeds, perhaps only 1 in a billion, will ever grow into a mature tree. The conditions must be just right. The soil must be mineral rich but not too wet or too dry. There must be adequate sunlight but not too much direct heat. And the seedling must avoid being eaten by the numerous animals that find the nutritious young shoots delectable. This is why natural sequoia reproduction often depends on periodic disturbances like fire. The heat opens the cones, the flames clear competing vegetation and enrich the soil with ash, and the newly opened canopy allows sunlight to reach the forest floor. In this brief window of opportunity, sequoia seedlings have their best chance to establish themselves and begin their long journey toward becoming the giants we admire today. It's a reproductive strategy that seems almost wasteful in its extravagance. Millions upon millions of seeds produced for each one that successfully matures. But when viewed across the time scale of these ancient beings, it makes perfect sense. A tree that lives for thousands of years doesn't need to succeed often, it just needs to succeed occasionally, creating enough new trees to maintain the species across deep time. This long-term perspective is built into every aspect of the sequoia's life history. They don't rush. They don't strive. They simply persist, growing slowly but steadily, reproducing patiently over centuries, adapting to challenges as they arise. Their strategy for survival isn't speed or aggression, it's patience and resilience. Qualities that have served them well through millions of years of planetary change. As the afternoon light shifts through the branches above, casting dappled shadows on the forest floor, consider what it would be like to experience time as these trees do. For them, a human lifetime passes in what we might consider a moment. The rush and hurry of our modern lives, our urgent deadlines, our constant connectivity, our impatience for results, would seem incomprehensible to beings that measure change in centuries rather than minutes. There's a lesson here perhaps about the value of the long view. In our fast-paced world, it's easy to become caught up in immediate concerns, to measure success by quarterly reports or annual reviews. But the sequoias remind us that some of the most enduring and significant processes unfold over time scales far beyond our usual frame of reference. What might we achieve, both as individuals and as a species, if we could cultivate some of that sequoia patience? What problems might we solve differently if we thought not just about the next few years but the next few centuries? How might we live differently if we saw ourselves not as isolated individuals but as links in a chain stretching back to the distant past and forward into the far future? As we continue our journey with these remarkable trees, we'll explore their place in human history and culture, the threats they face in our rapidly changing world, and the efforts being made to ensure that they continue their patient growth for millennia to come. For now, simply absorb the quiet wisdom of these ancient beings, letting their example of patience and persistence wash over you like the gentle shifting of sunlight through their towering canopies.
As the day progresses and shadows lengthen across the sequoia grove, let's delve deeper into the relationship between these ancient trees and human history. For while the sequoias have existed for millions of years, humans are relatively new arrivals in their story, and our impact on these ancient beings has been profound and not always positive. Indigenous peoples have lived among the sequoia and redwood forests for thousands of years. The Tula River tribe, Chumash, Miwok, Yurok, and many other Native American groups developed rich cultural relationships with these forests long before European settlers arrived. They viewed the massive trees with reverence, incorporating them into their spiritual practices and making careful, sustainable use of their resources. These indigenous communities harvested materials from fallen trees rather than cutting down living ones. They used the bark for building shelters and crafting containers, and they understood the role of fire in maintaining forest health, conducting controlled burns that prevented the buildup of dangerous fuel loads while promoting the reproduction of fire-adapted species like the sequoias. The relationship between indigenous peoples and these forests was one of respect and reciprocity, a balanced interaction that allowed both human communities and forest ecosystems to thrive for countless generations. The trees were seen not as resources to be exploited, but as elders to be respected, beings with whom humans shared the landscape rather than dominated it. This balanced relationship would change dramatically with the arrival of European settlers in the 19th century. The California gold rush of 1849 brought thousands of fortune seekers to the region, creating a sudden demand for timber to build mines, settlements, and infrastructure. When the newcomers encountered the massive sequoias and redwoods, they saw not ancient beings worthy of reverence, but valuable commodities ripe for exploitation. The logging of these ancient forests began in earnest in the 1850s, and the destruction was swift and devastating. Massive trees that had stood for thousands of years were felled in hours. Special techniques and equipment had to be developed to handle trees of such enormous size. Some were so large that they had to be blown apart with gunpowder before they could be transported to sawmills. Imagine the scene. Teams of loggers working with hand tools, axes, cross-cut saws and wedges, spending days cutting through the massive trunks. When a giant finally began to fall, the impact would shake the ground for hundreds of yards in every direction. The crash would echo through the canyon, followed by an eerie silence as birds and wildlife fled the disturbance. One particularly poignant account comes from a logger who helped fell a massive sequoia estimated to be over 3,000 years old. After the tree crashed to the ground, he counted the rings and realized that this single tree had been a seedling when the Egyptian pyramids were being built. The logger reportedly sat down on the massive stump and wept, overwhelmed by the realization of what had been lost in a few hours of human labor. The scale of destruction was immense. By some estimates, 95% of the original old-growth coast redwood forests were logged. The giant sequoias, with their more limited range, fared somewhat better, but many groves were severely impacted before protections were put in place. The wood from these ancient trees was used for a variety of purposes, from railway ties and fence posts to shingles and wine vats. Ironically, despite the effort expended to harvest these massive trees, the wood often proved disappointing for commercial purposes. Giant sequoia wood is brittle and tends to shatter when it hits the ground. Much of each tree was wasted, left to rot on the forest floor after only the most valuable sections had been removed. Some trees were cut down for even more trivial reasons. One massive sequoia, estimated to be 2,500 years old, was felled in 1853 simply to make a dance floor for miners. Others were cut down so their cross-sections or bark could be shipped to exhibitions in eastern cities and European capitals, where they were displayed as curiosities. One particularly notable example was the mother of the forest, a giant sequoia over 300 feet tall and 60 feet in circumference. In 1854, speculators stripped the bark from the living tree up to a height of 116 feet. The bark sections, some weighing as much as 2,000 pounds, were reassembled for exhibition in New York and London. Stripped of its protective covering, the tree died within a few years, though its massive trunk remained standing as a ghost-like monument to human short-sightedness for over 80 years before finally falling in 1908. But even as this destruction was taking place, a counter-movement was beginning. Some of those who encountered the sequoias were struck not by their commercial value but by their majesty and age. They began to advocate for the protection of these remarkable trees in the forests they inhabited. In 1864, in the midst of the Civil War, President Abraham Lincoln signed legislation granting the Yosemite Valley and the Mariposa Grove of giant sequoias to the state of California for public use, resort, and recreation. This was a landmark in conservation history, the first time the federal government had set aside land specifically for preservation and public enjoyment. This was followed in 1890 by the establishment of Sequoia National Park, the nation's second national park after Yellowstone. General Grant National Park, later incorporated into Kings Canyon National Park, was created the same year. These protected areas saved many groves of giant sequoias from the loggers' saw, preserving them for future generations. The movement to protect the coast redwoods came later, but was no less passionate. In 1918, the Save the Redwoods League was founded with the mission of protecting the remaining old-growth redwood forests. Through fundraising, advocacy, and strategic land purchases, the organization has helped protect more than 200,000 acres of redwood forests. These conservation efforts were revolutionary for their time. They represented a fundamental shift in how some humans viewed their relationship with nature, not just as a resource to be exploited, but as something of inherent value, worthy of protection for its own sake and for the benefit of future generations. The story of the sequoias in the late 19th and early 20th centuries reflects a broader tension in American society, between the drive for economic growth and material prosperity on one hand, and a growing awareness of the need to preserve natural heritage on the other. This tension continues to shape our relationship with these ancient trees and the forests they inhabit. As you walk among these giants today, it's worth remembering that many of them have lived through this entire human drama. The same tree, under which you might rest, has stood witness to indigenous ceremonies, felt the vibrations of loggers' saws, heard the debates of early conservationists, and now watches as tourists from around the world come to marvel at its size and age. What's most remarkable about these trees is not just their size or age, but their resilience, their ability to survive and adapt through dramatically changing conditions. They've endured natural disasters and human activities that have altered their ecosystems in profound ways. And in this resilience, there may be lessons for us as we face the uncertainties of our own future. Let's explore more deeply how these ancient trees actually function, the fascinating biology that allows them to grow so large and live so long. As evening approaches in our imaginary walk, the forest takes on a different quality. The direct sunlight fades, and the groves become filled with a soft, diffuse light filtering through the high canopy. The temperature drops slightly, and the air feels even richer with the scent of resin and earth. The secret to the sequoia's remarkable size lies in their highly efficient structure. Like all trees, sequoias conduct water from their roots to their leaves through specialized tissues called xylem. But the sequoias have developed a particularly efficient system that allows them to transport water to heights of over 300 feet, a feat that would be impossible with conventional plumbing. To appreciate just how remarkable this is, consider the physics involved. Lifting water 300 feet against gravity would require a pump generating over 130 pounds per square inch of pressure, more than most home water systems. Yet sequoias accomplish this without any mechanical pumps, using a fascinating process called transpiration. As water evaporates from tiny pores stomata in their needles, it creates a negative pressure that pulls more water up from the roots through continuous columns of water in the xylem. These water columns are maintained by the cohesion between water molecules and their adhesion to the walls of the xylem vessels. It's a passive but incredibly effective system that works because of the unique properties of water and the specialized structure of the tree. The tallest coast redwoods push this system to its physical limits. Scientists believe that 420 feet may represent the maximum theoretical height for a tree on Earth, limited by the physics of water transport against gravity. The fact that coast redwoods approach this theoretical limit is a testament to the evolutionary refinement of their internal structure. What's particularly fascinating is how these trees manage drought, a common challenge in their California habitat. During dry periods, sequoias can temporarily shut down parts of their water transport system, sacrificing some branches to ensure the survival of the whole. They've also developed specialized foliage that can absorb moisture directly from the coastal fog in the case of coast redwoods, or from snowmelt for the giant sequoias in the Sierra Nevada. The age of these trees gives them an almost unimaginable perspective on climate change. Individual sequoias have lived through multiple periods of warming and cooling, including the medieval warm period, approximately 950–1250 CE, and the Little Ice Age, approximately 1300 to 1850 CE. Their growth rings provide scientists with valuable data about historical climate patterns, serving as natural archives of environmental change. By examining the width of these growth rings, researchers can determine which years were favorable for growth and which were challenging. Wider rings indicate years of abundant rainfall and moderate temperatures, while narrower rings suggest drought or unusually cold conditions. Some sequoias have over 3,000 annual rings, offering a climate record that extends back to the time of the ancient Egyptians. This long-term perspective is particularly valuable as we face the challenges of human-induced climate change. The relationship between sequoias and fire has also evolved over millennia. These trees aren't just fire-resistant. They're fire-adapted, meaning fire plays an essential role in their life cycle. The heat from fires helps release seeds from their cones, clears the forest floor of competing vegetation, and creates the ash-enriched soil that sequoia seedlings need to establish themselves. For thousands of years, natural fires ignited by lightning swept through sequoia groves every 5 to 15 years. These were typically low-intensity fires that cleared underbrush without threatening mature trees. Indigenous peoples recognized the importance of these fires and conducted their own controlled burns to maintain forest health. However, European settlement brought a policy of aggressive fire suppression. Beginning in the early 20th century, forest managers worked to extinguish all fires as quickly as possible, believing they were protecting the forests. This well-intentioned policy had unintended consequences. Without regular fires to clear underbrush, forests became increasingly dense with smaller trees and accumulated fuel, setting the stage for more catastrophic fires. When fires do occur in these fuel-laden forests, they burn hotter and climb higher, reaching the canopies of even mature trees, creating crown fires that can kill even fire-adapted species like sequoias. Recent years have seen devastating fires in both coast redwood and giant sequoia habitats, with thousands of mature sequoias, trees that had survived for centuries or millennia, lost to unnaturally intense blazes. Forest managers now recognize the importance of fire in these ecosystems and have reintroduced controlled burns in many protected areas. These carefully managed fires mimic the natural fire regime that shaped these forests for millions of years, reducing fuel loads and promoting sequoia reproduction. As night begins to fall in our imaginary journey through the sequoia grove, the forest takes on yet another character. The massive trunks become silhouettes against the darkening sky, their upper branches disappearing into the gloom. The forest grows quieter, with daytime birds falling silent as nocturnal creatures begin to stir. In this tranquil evening setting, let's consider the countless nights these trees have experienced, perhaps 3,000 years of nights for the oldest individuals. They've stood through countless storms, felt the seasons change more than 1,000 times, and witnessed the slow dance of stars across the sky as Earth's axis has wobbled in its 26,000-year precession cycle. During their long lives, these trees have absorbed enormous amounts of carbon from the atmosphere, helping to regulate Earth's climate. A single mature giant sequoia can contain more than 400 tons of carbon, making them some of the most carbon-dense organisms on the planet. The oldest groves represent massive carbon reservoirs that have been accumulating for thousands of years. This carbon sequestration role takes on new significance in our era of climate change. Protecting and restoring sequoia and redwood forests isn't just about preserving natural heritage, it's also about maintaining critical carbon sinks that help mitigate the effects of human greenhouse gas emissions. Beyond their ecological importance, these ancient trees have profound cultural significance. They've inspired artists, writers, philosophers, and spiritual seekers. Their immense size and age evoke feelings of awe and humility. Standing beside a living being that was already ancient when most of our religious texts were written provides a perspective that few other experiences can match. John Muir, the influential naturalist and environmental philosopher, wrote eloquently about his encounters with the sequoias. In his 1912 book The Yosemite, he described them as nature's forest masterpiece, and so far as I know, the greatest of living things. He advocated passionately for their protection, seeing in them not just biological wonders, but spiritual significance as well. The king sequoia, he wrote, they seem to me the priests of the pines, ever pointing upward, keeping an eternal summit watch over all the other tree people about them, sharing in the sublime endurance of the mountains. Ansel Adams, the renowned photographer, captured the majestic presence of these trees in black and white images that helped build public support for both species. Show remarkable genetic diversity despite their limited ranges and the reduction of their populations. This diversity has helped them adapt to changing conditions over millions of years and may be crucial for their survival as they face the challenges of climate change, invasive species, and other modern threats. As our imaginary day in the sequoia grove comes to an end and stars begin to appear between the massive branches overhead, let's reflect on what these trees might teach us about our own place in the world. Perhaps their most powerful lesson is one of perspective, both temporal and spatial. We humans tend to think in time frames of days, years, or at most decades. Our politics, economics, and personal planning rarely extend beyond a few generations. Yet here stand beings that have lived through the rise and fall of empires, through dramatic climate shifts, through the entire span of recorded human history. What might we do differently if we adopted something of the sequoia's long-term perspective? How might we approach environmental challenges, resource management, or social institutions if we thought not just about the next quarter or election cycle, but about the next century or millennium? The sequoias also offer a lesson in interconnection. Despite their imposing size and apparent self-sufficiency, these trees depend on complex relationships with fungi, insects, birds, mammals, and even fire. They don't exist in isolation but as part of intricate ecological communities. Their roots intertwine underground, sometimes even grafting together to share resources and support each other through storms and droughts. In a world that often celebrates individual achievement and self-reliance, the sequoias remind us that even the mightiest beings thrive through connection and mutual support. Their success over evolutionary time hasn't come from dominating their environment, but from finding a sustainable place within it. And finally, these ancient trees offer a lesson in resilience. They've survived countless challenges over millions of years: climate shifts, fires, storms, disease outbreaks, and more recently, human exploitation. They've done so not through rigidity but through adaptation, not through fragility but through remarkable toughness combined with flexibility. This resilience is something we might aspire to cultivate, both individually and in our societies. Not the brittle strength that breaks under pressure, but the supple endurance that bends without breaking, that recovers from damage, that adapts to changing conditions while maintaining core integrity. As night fully descends on our sequoia grove, and the massive trunks become shadowy presences in the darkness, there's a palpable sense of continuity, of being in the presence of beings that have seen countless nights come and go, and that will likely stand witness to many more, long after we ourselves have passed from the scene. As we near the end of our journey with these remarkable trees, you might be wondering about their future. What challenges do they face in our rapidly changing world? What is being done to protect them? And perhaps most importantly, what will these ancient forests look like in 100 years, or 1,000? The dawn breaks gently over the sequoia grove, bathing the massive trunks in soft golden light. Morning mist weaves between the trees, creating an almost mythical atmosphere. This tranquil scene belies the significant threats these ancient forests face, threats unlike any they've encountered in their millions of years of evolution. Climate change represents perhaps the most pervasive challenge. Both giant sequoias and coast redwoods evolved under specific climate conditions, the former adapted to the cool, relatively dry climate of the Sierra Nevada mountains, with significant winter snowfall, the latter to the foggy, mild coastal environment of Northern California. As these conditions shift due to global warming, these specialized trees may find themselves increasingly stressed. For the giant sequoias, diminishing snowpack in the Sierra Nevada mountains is particularly concerning. These trees depend on the slow spring melt of winter snow to provide moisture during the growing season. As winters become warmer and more precipitation falls as rain rather than snow, the natural irrigation system these trees have relied on for millennia is being disrupted. Coast redwoods face a different but related challenge. They've evolved to capture moisture from the coastal fog that regularly blankets their habitat. Research indicates that these fog patterns are changing as ocean and air temperatures rise, potentially reducing this crucial water source. Some studies suggest that coastal fog has already declined by as much as 33% over the past century. Both species have survived previous climate shifts, of course, but the current rate of change is unprecedented in their evolutionary history. Natural climate fluctuations typically occur over thousands of years, giving trees time to adapt or migrate. Today's human-induced climate change is happening over decades, a mere blink of an eye for species that live for millennia. Compounding this challenge is habitat fragmentation. The remaining old-growth forests exist as islands in a landscape altered by human development, making it difficult for these species to migrate to more suitable habitat.
Hotter, drier conditions create more intense fires that can reach the canopies of mature trees. The 2020 Castle Fire in California's Sierra Nevada mountains was particularly devastating, killing an estimated 10 to 14% of all large giant sequoias in existence, trees that had survived countless fires over centuries or millennia. The 2021 fire season brought further losses, with the canopy complex and windy fires impacting several more sequoia groves. For coast redwoods, increased drought stress makes trees more vulnerable to disease and insect attacks. While these trees have powerful natural defenses, prolonged stress can weaken them, making them susceptible to pathogens they might otherwise resist. Scientists are monitoring several fungal diseases that could pose threats to stressed trees. Tourism, while economically valuable and important for building public support for conservation, brings its own challenges. Popular groves can suffer soil compaction from thousands of visitors, affecting root systems and water absorption. Noise and disturbance can impact wildlife that play important roles in the forest ecosystem. Yet despite these challenges, there are reasons for hope. Significant efforts are underway to protect and restore these ancient forests, combining traditional conservation approaches with innovative new strategies adapted to emerging threats. Protected areas have been expanded in recent decades. Organizations like Save the Redwoods League, the Sempervirens Fund, and others continue to purchase key forest lands for conservation. These protected areas provide crucial habitat, not just for the iconic trees but for the entire ecological communities they support, from soil microorganisms to large mammals. Restoration work is ongoing in many areas, particularly in coast redwood regions where second-growth forests, those that regrew after logging, are being managed to eventually develop old-growth characteristics. While a truly ancient forest can't be created overnight, careful management can accelerate the development of important structural features like multiple canopy layers, large deadwood components, and diverse understory vegetation. Fire management has evolved significantly. Rather than attempting to exclude fire entirely, land managers now recognize the importance of controlled burns that mimic natural fire regimes. These carefully managed fires reduce fuel loads, create appropriate conditions for sequoia reproduction, and help maintain forest health. Indigenous knowledge is increasingly being incorporated into these practices, recognizing the sophisticated understanding of fire ecology developed by Native Americans over thousands of years of living with these forests. Scientific research continues to deepen our understanding of these remarkable trees and the ecosystems they create. Genetic studies are mapping the diversity within sequoia populations, helping identify genetic resources that might be crucial for adaptation to changing conditions. Physiological research examines how these trees respond to drought, heat, and other stressors, informing conservation strategies. Perhaps most encouragingly, public awareness and support for protecting these ancient forests continues to grow. People from around the world visit sequoia and redwood groves, often describing the experience as transformative. This tourism creates economic incentives for conservation, while building a constituency of supporters who understand the value of these forests. Education programs reach thousands of school children each year, instilling an appreciation for these ancient trees in the next generation. Citizen science initiatives engage the public in monitoring forest health, collecting data that would be impossible for professional scientists to gather alone. Conservation organizations are also thinking beyond traditional protected areas, developing corridors to connect isolated groves, and working with private landowners to improve forest management across the landscape. These approaches recognize that effective conservation requires thinking at the ecosystem level rather than focusing solely on individual groves or trees. Climate adaptation strategies are being developed specifically for these forests. These include identifying and protecting climate refugia, areas that are likely to maintain suitable conditions even as the climate changes, as well as assisted migration of genetic material from populations that may have adaptations valuable in warmer, drier conditions. In some areas, particularly vulnerable to climate impacts, more interventionist approaches are being considered, such as supplemental irrigation during extreme drought or selective thinning to reduce competition for water. While such approaches would have been considered inappropriate in the past, the unprecedented nature of current threats has led to a re-evaluation of what constitutes appropriate conservation action. The growing recognition of the carbon sequestration value of these forests adds another dimension to conservation efforts. As governments and corporations seek ways to offset carbon emissions, the protection and restoration of sequoia and redwood forests offer significant potential. A mature redwood forest can store more carbon per acre than any other forest type on Earth, making their conservation valuable not just for biodiversity and cultural reasons, but as a climate mitigation strategy. What might the future hold for these ancient forests? While no one can predict with certainty, several possible scenarios emerge from current trends and scientific understanding. In the most optimistic scenario, comprehensive climate action reduces greenhouse gas emissions rapidly, limiting warming to levels these trees can adapt to. Protected areas expand, connecting isolated groves and providing migration corridors. Restoration efforts allow second-growth forests to develop old-growth characteristics over the coming centuries. Fire is managed thoughtfully, with controlled burns mimicking natural fire regimes. With these conditions, sequoias and redwoods could continue their long journey through time, perhaps witnessing another few thousand years of human history, while maintaining their ecological and cultural significance. A more challenging scenario sees continued warming, but with substantial adaptation efforts. Some groves in particularly vulnerable locations might be lost, but strategic protection of climate refugia allows the species to persist. Active management becomes more common, with irrigation, thinning, and other interventions helping trees through the most difficult periods. The forest changes but remains, though perhaps with fewer of the truly ancient individuals that inspire such awe today. In the most pessimistic scenario, unchecked climate change creates conditions beyond the adaptive capacity of these species in their current ranges. Despite conservation efforts, many groves are lost to fire, drought, or disease. The species might not go extinct entirely. Both can be cultivated in suitable climates around the world, but the ancient forests as we know them, with their complex ecological relationships and trees that have witnessed thousands of years of history, could largely disappear. The actual future will likely fall somewhere between these scenarios, varying by region and influenced by both environmental factors and human choices. What's clear is that the fate of these forests is now inextricably linked to human decisions about climate, land use, and conservation priorities. As we reach the end of our day's journey through the sequoia grove, the setting sun casts long shadows from the massive trunks, creating a cathedral-like atmosphere of alternating light and darkness. The forest grows quiet as daytime birds settle for the night, and the first stars appear in the darkening sky, visible through gaps in the high canopy. In this peaceful moment, surrounded by beings that have survived for millennia, it's natural to feel both humbled and inspired, humbled by their age and size, by the brief span of our own lives compared to theirs, by the realization that they were ancient when our oldest institutions were just being formed, inspired by their resilience, their quiet persistence, their ability to weather countless challenges while continuing their slow, steady growth toward the sky. Perhaps this is the true gift of time spent among these ancient trees, a shift in perspective, a gentle reminder of our place in the larger web of life and the deeper currents of time. Not to diminish the importance of human life and activity, but to place it in a broader context, not to escape responsibility for our impact on the natural world, but to understand that impact more fully, and perhaps to approach it with greater wisdom. As you walk back through the twilight forest, the massive sequoias now shadowy presences in the gathering darkness, you might feel a connection to these ancient beings, not mystical or supernatural, but the simple recognition of shared existence on this planet, albeit at very different scales of time and size. You might also feel a responsibility, not burdensome but meaningful, to ensure that these remarkable trees, and the forests they create, continue their journey through time, that future generations have the opportunity to stand where you've stood, to look up and wonder at living beings that have witnessed thousands of years of Earth's history. This responsibility doesn't require grand gestures. It might be as simple as supporting conservation organizations, making climate-conscious choices in daily life, sharing what you've learned about these trees with others, or simply visiting these forests with respect and care.
In the end, the story of the sequoias and redwoods is still being written, and we are now co-authors of that story. The choices we make, individually and collectively, will help determine whether these ancient trees continue their long watch over the changing world, whether they add another few thousand years to their already impressive lifespan, whether they continue to inspire wonder and perspective in generations yet unborn. As night falls completely on our journey, and the forest becomes a realm of shadows and subtle sounds, we leave the sequoias to their patient growth, to their quiet persistence, to their ancient dreams beneath the stars. But we take with us something of their perspective, their resilience, their deep connection to time and place, and perhaps that's the most valuable souvenir of all. As our time together among these ancient giants comes to a close, let's take a moment to reflect on our journey. We've explored the deep history of the sequoias, from their prehistoric origins millions of years ago to their current status as some of Earth's most remarkable living monuments. We've examined their extraordinary adaptations that allow them to grow so large and live so long, their complex relationships with fire and other elements of their ecosystem, and their place in human culture and imagination. We've also confronted the challenges they face in our rapidly changing world, and the efforts being made to ensure their continued survival. Through it all, these trees have emerged not just as biological wonders but as teachers of sorts, offering lessons in patience, resilience, interconnection, and the long view of life. Now, as you prepare for sleep, let the peaceful presence of these ancient beings linger in your mind. Imagine once more standing among them, looking up at their towering heights, feeling the soft forest floor beneath your feet, breathing the resin-scented air. In the quiet of the sequoia grove, time seems to slow down. The urgent pace of modern life feels distant, and somehow less important. Here, surrounded by living beings that measure their lives in millennia rather than years, perspective shifts. The concerns that seemed so pressing just hours ago appear in a different light. This is perhaps the greatest gift these ancient trees offer us, not just their beauty or ecological value, but the profound shift in perspective they invite. In a world that often demands immediate attention, immediate results, immediate everything, the sequoias remind us of a different way of being. They embody a patience, measured not in minutes or hours but in centuries and millennia. Their slow, steady growth, adding cells to their massive trunks at a pace imperceptible to human senses, continues regardless of the dramas playing out around them. They don't rush, they don't multitask, they simply persist, growing toward the light, with quiet determination, adapting to challenges as they arise, enduring through times both favorable and harsh. There's wisdom in this patient persistence, a reminder that some of the most enduring and significant processes unfold at a pace far slower than our usual attention span. Growth, whether of a tree, a relationship, a community, or an idea, often happens gradually, invisibly, revealed only when we step back and take the longer view. The sequoias also remind us of our place in the greater web of life. Despite their imposing size and apparent self-sufficiency, these trees exist as part of complex ecological communities. Their roots intertwine with fungal networks that connect them to other trees and plants. They provide habitat for countless organisms, from microscopic bacteria to nesting birds to the occasional black bear scratching its back against their massive trunks. In this way, they mirror our own existence, seemingly independent yet profoundly connected, shaped by relationships both seen and unseen. Their individual majesty doesn't diminish these connections. It arises from them just as our own uniqueness as humans emerges from rather than exists in spite of our relationships with others and with the natural world. As you drift toward sleep tonight, carry with you this sense of connection, to time, to nature, to the long story of life on earth. Let the image of these ancient trees, with their feet planted firmly in the soil, and their crowns reaching toward the sky, remind you of your own place in the world, rooted in the past, present in the moment, reaching toward the future. Perhaps, as consciousness begins to fade, and your breathing deepens, you might imagine yourself as one of these ancient trees. Feel your roots extending deep into the earth, drawing nourishment from the soil. Feel your trunk standing strong, supporting the weight of your branches and leaves. Feel the air moving through your needles, the gentle exchange of oxygen and carbon dioxide that connects you to all breathing things. In this peaceful state, halfway between waking and dreaming, the boundaries between self and world may begin to soften. The sharp edges of identity and separation give way to a gentler sense of belonging to something larger, the forest, the planet, life itself. This is not mystical thinking, but simply the recognition of a biological reality. We are not separate from nature, but part of it, as surely as the sequoias are part of their forest ecosystem. This recognition doesn't diminish our individuality, it enriches it, placing our unique existence within a larger context of relationship and meaning. Just as each sequoia is distinct, shaped by its specific location, the particular challenges it has faced, the unique pattern of its growth, yet also part of the greater community of the forest, so too are we both individual and connected, both unique and part of something larger than ourselves.
As sleep approaches, let go of any need to hold on to these thoughts analytically. Allow them to settle into a felt sense of peace and belonging. Let the ancient rhythm of the forest, the slow cycle of growth and rest, the patient accumulation of experience, the deep connection to place, become your own rhythm for a time. The sequoias have witnessed countless nights like this one, countless beings drifting into sleep beneath the canopy of stars. They've stood through stormy nights and calm ones, through nights lit by fire and nights dark as ink, through nights when humans first arrived in their groves and nights when no human footsteps disturbed the forest floor. Through it all, they've continued their slow, patient growth, adding another microscopic layer of cells, extending roots a tiny bit deeper, reaching branches a fraction of an inch higher, not striving, not rushing, simply being and becoming in their own time and way. Tonight, as you rest, you participate in this ancient rhythm of renewal. Sleep is, after all, when much of our own growth and healing takes place, when memories are consolidated, when cells are repaired, when the day's experiences are integrated into the ongoing story of our lives. Like the sequoias adding another ring to their massive trunks, you add another day to your life's growth, another small layer to the person you are becoming. And just as the sequoias need periods of dormancy, winter's quiet, when growth slows and energy is conserved, so too do we need the deep rest that sleep provides. In this rest, there is no failure, no falling behind, no lost productivity. There is simply the necessary pause that makes continued growth possible. So as our journey together comes to a close, and you settle into this time of rest, know that you carry something of the sequoias with you. Their patience, their resilience, their deep connection to time and place. These qualities don't belong to the trees alone. They are birthright of all living things, available whenever we slow down enough to remember them. May your sleep be peaceful, your dreams gentle, and your waking refreshed. And perhaps someday you might walk among these ancient giants yourself, feeling the soft forest floor beneath your feet, breathing the resin-scented air, looking up at their towering heights with wonder. Until then, they continue their patient growth, their quiet witness, their ancient dreams beneath the stars. Good night. And thank you for sharing this journey through time and forest with me. Sleep well.